what surprised you, what we've missed, what are the good research questions, what are the things we should be thinking about for the next conference. So with that, let's move to the presentation by Nurul Mahmood. Over to you.
And thanks. So good afternoon, everyone. My name is Nurul Mahmood. I'm from the 6G Flagship Research Program at the University of Oulu. And thank you for inviting me to participate and to talk at this conference. It's my pleasure being here. Today, I'm going to talk a little bit about this resilient by design framework, especially focusing on future wireless networks. But of course, this framework is general and it can be applied to different systems. I think I have about 10 minutes or so, so I'll try to keep my time within that limit. Okay, so a little bit about Oulu, just to brief you, for those of you who are not familiar. So Oulu is a city in north of.
They're on the sides.
Okay, good.
Oulu is a city in the north of Europe, and it's one of the largest cities in the north of Europe, actually. And the university is fairly young. It's about 65 years old and about mid-sized university with 14,000 students and 4,000 staffs. And our research strengths are mainly focused on ICT and digitalization, health and well-being, and materials and space. A little bit about this research 6G flagship research program. So this is the world's first and the largest academic research program on 6G. Research in this program is focused on 4 different strategic research areas. That is wireless connectivity, devices, distributed intelligence, and then services and applications. And this picture here, this picture is just to highlight that we're not doing research only on the technological aspects of 6G, but also on, for example, business model, regulation, and sustainability. So it aligns well with this spectrum research going on at Silicon Flatirons. So we have been researching 6G, and here is, let's say, somehow the main drivers of different wireless generations from 4G up to 6G, right? But what happens after 6G? So after some brainstorming, we came up with this statement that we believe beyond 6G, so wireless network after 6G will be mainly focused on resilient and sustainable AI-driven society. So basically delivering value to this society. Right. So here you can see resilient is one of the key words for next or beyond 6G wireless system. And let's talk about resilience for the rest of this presentation. Okay. So firstly, what and why? Why do we need resilience and what it is? Okay. So resilience, there are many different definitions of resilience, but the one that we have adopted is that resilience is the ability of a network or a system to continue operating correctly during and after a natural or man-made disturbance. And here we may highlight that most of the time these disturbances are unknown or unpredicted disturbances. Yeah. So resilience has 2 aspects. Firstly, maintaining quality of service in the face of disruptions. Basically, how do you continue to deliver service even in the face of disruption? And the second thing is the quality of remediation or recovery. That means once a failure happens, once you have a degradation, how quickly and how well can you recover, jump or come back from this failure back to the normal state. Yeah. And most often or sometimes resilience is mistakenly used synonymously with these 2 other terms, reliability and robustness, but actually they are quite different, as you can see from this figure here. So resilience subsumes these 2 other aspects. Reliability is the ability to perform as required for a given time interval. So basically, it means that how well can you deliver a certain service. On the other hand, robustness is defined as the ability to continue operation in the face of known challenges. So basically, a robust system is a system that caters to some known failures, right? Some failure that you know it can happen. Right? And you make a system robust against those kind of failures. Yeah. So we have talked about what is resilience, and let's quickly see why is it important, or why do we need to talk about resilience? So firstly, resilient by design has been designated as one of the common design principles for 6G and beyond 6G. So this was a statement that was endorsed by more than 10 like-minded nations, including the US, where they have defined resilience along with two other things as one of the main design principles for 6G and beyond 6G network. Why is resilience so important? Of course, there are many reasons, but I want to highlight four here. So first, because systems are becoming more and more complex day by day, right? And that means you have more sources of failures, more variation in the failures, and so on. Secondly, you have this increasing unpredictability. It can be because of adverse weather effects, that extreme weather events are happening more and more frequently nowadays. It can be due to geopolitical tensions and other factors, right? So you have more and more sources of failures and unprediction in the network. Third is this technological interdependence. So we have multiple systems, different systems that work very closely with each other. For example, the communication network depends a lot on the energy network, right? So you have this dependence between different systems, which also leads is a source of problem. And finally, shifting paradigm from prevention to adaptation. So previously systems were designed to be, let's say, bulletproof, fail-safe. Whereas now we have accepted that failures will happen, and then we are looking into how we can make systems that adapt to these failures and that can overcome these kind of shocks and recover quickly from such disruptions. Okay. So this is basically highlights why we need to talk about resilience. In the next part of this presentation, let's see a little bit about how do you make a system resilient. Of course, this is not the solution to all the problems, but this is just one proposal that we have put forward in this publication, which you can see here, which gave a framework on how to make systems resilient by design. Okay. So here we have four aspects, and let me go through them one by one. The first part is prediction. So basically, prediction means that we need to employ advanced techniques to monitor and predict different failures, right? If you recall, we have said that resilience also, we need to make a system resilient against unknown failures. So we need to be able to predict when, let's say, known failures happen, but at the same time also detect when an unknown failure happens. Yeah. And here we have proposed, or we have outlined three different approaches that can be taken. The first is a model-based approach, basically using our extensive domain knowledge to predict such failures. Secondly, data-driven approaches. So basically using these advances in AI techniques, for example, machine learning techniques or time series models and so on, to predict and detect failures. And third is using advanced techniques, for example, integrating digital twins with the real life system so that we can, monitor the system behavior in real time. Second is preemption. Preemption means that once you have detected a failure or once you have predicted a failure to happen, we can take preemptive measures so that this failure does not happen. So we can try to take proactive action so to prevent this failure from happening. And here, for example, you can take proactive resource management techniques. We can employ network routing resilience. So for example, proactive rerouting for predicted node failures, or also from the security perspective, we can take some sort of preemptive measures. For example, zero trust architecture, where you have continuous authentication and authorization for all devices to prevent security mishaps. The third part of this framework is the protection part. That means once a failure happens, because we know that we cannot make systems fail-proof, so failures will happen. How do you recover from this failure? So this is the quality of remediation or quality of recovery that we talked about earlier, right? And here we have outlined four different strategies. So for example, isolation mechanism. These networks are evolving towards this network of networks architecture, where networks are built, you have sub-networks as part of the bigger network. So if a failure happens in one sub-network, you can isolate that network so that the failure does not propagate to other parts of the network. We can also have differentiated service level management. So you can have different levels of service. So if a failure happens, you may not be able to deliver the complete service, but you can deliver like partial service and still keep some sort of services ongoing. Then you can have this traffic engineering. So for example, how do you prioritize these critical and delay sensitive services? And lastly, you can have novel network architecture, for example, integrating aerial networks like drones and HABs so that you have a different layer of the network as a redundant layer. The final part of this framework is the progression part. That means this is the part that says that how do you continuously learn and update your system based on what is happening. And here we can have dynamic model updates. So basically updating the parameters of the different models or adopting new tools. We can also have refinement, for example, integrating new observation data and also applying transfer learning to transfer the model learned in one system to another system. And finally, we can have holistic assessment, for example, like continuously keeping track of the key performance indicators to monitor how the system is performing, and also looking into these trade-offs, because whatever system we design will have different trade-offs. So trying to, like optimize the trade-off on the go. So with this 10 minutes that I had, I just tried to answer these 3 questions here. So first was resilience. What is resilience and why? Second is how do you ensure this resilience? So these are the 3 things that I covered or wanted to cover in this talk. So to summarize, we can say that resilience will be a critical defining feature of future systems, including wireless system, but of course not limited to that for different systems. And network resilience aims to maintain an acceptable level of service, even under unpredictable and challenging conditions. So basically, when you say that a system is resilient, we want to make sure that this system is able to deliver the service that it wants to deliver, even when you have some sort of failures. Okay? And here, of course, we had one solution or one proposal for a resilient by design framework for systems, which had these 4 steps: prediction, preemption, protection, and then progression. And finally, I would say that resilience is a cross-disciplinary topic. So it cannot be solved by like one discipline by itself. So we need interdisciplinary collaboration in research to solve this, let's say, major or this big research problem of resilient or designing resilient systems. With that, I would like to conclude and thank you for your attention, and I'll be happy to take questions if you have any. I hope I was not over time.
That was great. Thank you very much, Nurul. And just for those in the audience who want to follow up, there is the 6G resilience white paper. You had the QR codes. And also for the more technical drill down, there was a paper by Nurul and his collaborators in IEEE Communications Mag. So turning it over to John and Peter, do you have any thoughts or questions for Nurul?
Can I go first?
Go ahead.
Yes, Nurul, thank you so much. Really appreciate you sharing this with us. The framework is general and extremely helpful. And while you're going through it, you were talking about it at the level of an individual network. But in my mind, I was thinking that the regulator also does this at the overall spectrum ecosystem level. They're predicting and preempting and protecting and progressing. Mm-hmm. So there's 2 of these loops that are happening at different timescales. But actually, there might be some synergy, some ways that the regulator could do things, establish conditions that make it easier for the network to do this, and things the network could do to help the regulator. So I'm wondering if that discussion is happening in your broader project or in Europe, that sort of interaction towards resilience between the network design and the regulatory environment. And just curious to hear what's happening or thinking about that. Thank you.
Thanks, John. So I think that's a very interesting question. And of course, that's a very valid point that, like you have this kind of outer loop where things are happening at much slower time scale. And then you have this somehow inner loop of the system where things are moving much at a much fine-grained time scale. I would say that this discussion is something that would be very useful, but unfortunately, as far as I know, maybe I'm wrong, it's not happening at the level that we would like it to happen, right? So basically you have, that's the regulators imposing something, and then that is stagnant or that is like somehow fixed for a longer duration. And then the system and the network is trying to, adopt or develop itself within the framework given by the regulator. But this kind of going back and forth communication is not happening at the level that we would like to have, would like it to happen. I would say that. So yeah, I mean, this is something that needs to be done, but probably still we have something to do about it.
Thank you. Peter?
Hi, Nurul. This is Peter Tenhula. My question is kind of general in the sense of how you apply a framework like this, you know, in maybe other contexts, especially we were talking here about other more, you know, kind of systems that are more critical than consumer level, you know, wireless, no offense. But my question, I guess, relates to where does this take place? Is it from a business standpoint? Is this a carrier that does this internally, or is this something that happens among carriers? Some kind of federation of problem solving that goes on, or maybe even a third party?
Yes, I think that's also a very nice remark. So thanks for your remark. I would say that this framework that we have proposed here, of course, it's an academic paper, so it's very abstract still. And it can, I mean, this kind of general framework can be applied at different levels. It can be in one system, as you said, or it can be across different carriers, and also like maybe a third party that maintains this, or at least that maintains part of this, some of the blocks of this framework. So the actual implementation of this framework is still open. I mean, here we have just approached it from a very academic perspective and trying to see like how we can design a system to be more resilient. And as the other point that you noted here is that this is, of course, like we are not looking to extremely critical features or extremely critical networks. It can be like, for example, you can have industries that require very mission critical service delivery, right? There, the design objectives might be a bit different, so we need to think a bit differently here. But what we have proposed in this presentation and what we have talked also in the paper is a more generic framework that is like, I would say, more for the consumer level. But if you have other systems or other networks where you need to deliver critical services, where, for example, some aspects of the service delivery is more important than others, then of course you need to adapt the system for that.
Thank you very much, Nurul. I have many questions. I'll just ask one, which is, given the time that you have, you weren't really able to speak to it, but it's something that you discuss in some depth in your white paper. 6G has three key design goals, and they are resilience, efficiency, and sustainability. Presumably there are trade-offs between those. Can you talk about the trade-offs between resilience and efficiency? Is it a zero-sum game, or does increasing resiliency help with the others?
Yes, of course, there's this trade-off between resilience, sustainability, and efficiency. So they can be seen as, let's say, three corners of a triangle that makes, let's say, 6G. Now, which part of the triangle that you want to focus on depends on what kind of service you want to deliver, right? As you know that in starting from 5G, actually, wireless communication had a paradigm shift. So up to 4G, basically, wireless communication was mostly focusing on consumer services. So basically delivering higher bit rates and so on. But 5G introduced the notion of this multi-service communication where you have URLLC, like ultra reliable low latency communication, you have machine type communication, and also you have the conventional broadband communication. So moving to 6G, of course, this multi-service paradigm will continue. And here then, which part of the trade-off that you want to focus on, it also depends on which service you want to deliver, right? So if you have certain services, for example, like if you want to provide the connectivity in a factory that requires very high quality of service, then you will maybe focus on resilience more than sustainability or efficiency, because cost may not be your primary design goal here, right? So I think this trade-off is very much application dependent. It depends on which application or which service you want to serve or deliver. And also the question about the zero-sum game, that I can't say for sure because I don't have sufficient knowledge to say that. But of course, if you want to focus on something, that you may need to pay a price in terms of the others. But if a system is very well designed, then having more resilience would also mean more efficiency, because one of the aspects of resilience is that you deliver the service the level that is needed. So you will not over-engineer or over-provision a service. Okay. Of course, that then leads to efficiency. So if it's done well, then of course, one aspect will benefit the other. But exactly how this happens, of course, I don't have enough expertise to talk much about that.
Thank you very much. We'll let you go. It's very early. We really appreciate that you spent some time with us, and we hope we can actually host you here in Boulder in person in the future. Thank you very much.
Thank you. It's my pleasure to be here, and thanks for the invitation.
So turning to our two moderators, and then we'll turn to you in the audience for your reflections on what we've been talking about and what the key takeaways should be.
Yes, just a very quick thought on this morning's, we were asked to reflect on each other's panels. So when I think about the lessons from the airwaves, Peter's panel, I hear a common theme coming across many of the examples is just the critical importance of information gathering. And I'm wondering if that might lead to a path forwards for us as a nation. So I'll be a little more specific. I think of things in terms of the old OODA loop: observe, orient, decide, act. So observe is you're gathering the information, orient is you're figuring out what it means, which in this case would mean interpreting that RF data. Decide is deciding whether something is actually a problem, and if so, what you're going to do about it. And then the action is carrying out that enforcement or mitigation action or whatever. We're in a world where we have very limited resources to mitigate and enforce, and that will probably be true for a long time. And we have a very large and complex environment with many things going on. And I heard many examples where basically the real challenge and the real goal was to neck down to what are the things we should actually try to fix. So Julie said, hey, when there's interference, the first thing you got to do is find out, is everything playing by the rules? Are things operating where they shouldn't? Are things operating at too high a power? That's fundamentally an information gathering and orientation problem before you even get into any kind of enforcement. Jeremy told us that field offices get over 1,000 complaints a year, but many, or maybe even most, are not actually interference. Those are defective devices or bad configuration. And Henning told us that certainty of enforcement is often more important than severity, right? Well, the way you get to certainty is by having fairly comprehensive information gathering, so that when somebody does step out of line, you can actually give them that very cheap camera ticket or whatever, but that's a pretty effective method. So I wonder if it would be reasonable for us as a community and a nation to maybe not think too hard about new methods for the back half of this, which is the deciding whether we're going to enforce and then enforcing or mitigating. Maybe we just rely on existing mechanisms for that for a while, and we really focus on getting super good at the observe and orient challenges. Let's respond to Henning's comment about scaling up and using digital systems. Let's take advantage of digital license plates. Let's figure out how to crowdsource, as Jade was talking about. Let's figure out how to solve privacy issues and maybe create new regulatory structures that allow us to do what we need to do. Let's focus on, that's the message I was taking from all of those experiences. Let's focus on the observe and orient challenges first, make rapid progress there, and then come along later with better solutions at the back end. Over to you, Peter.
All right.
Wait, was somebody speaking?
Hello. Oh, it's an echo. In a canyon. Hello.
Observe.
God, we even hear Julie. I think we've been invaded by Oh. Okay. What was that? O? What was O? O?
No, no, no. In my case, it was uh-oh.
So my key takeaway or kind of real question from John's panel was what really needs to be resilient? You know, and you know, I think that Paul kind of talked about the must-haves. We had a few of the critical users. You know, some say it's critical infrastructure. Here we had public safety represented, the weather and the scientific side of things. And, you know, also national security was mentioned. If we had somebody from aviation, I'm sure they would raise their hand too to say we're in that camp too. So my takeaway was that maybe that's the area of critical focus. You know, is that, you know, where does the resilience, reliability, redundancy need to be, you know, and I keep hearing on the reliability side, oh, we got to have 5 nines, right? And sometimes people say, oh, we have 10 nines, whatever. How many nines of reliability? But nobody asks them, well, how many nines do you have now? And how are you going to get to 5? What do you think is the path to get to 5 nines? You know, so we start with public safety, you know, as the preeminent, or GPS or something like that. You know, what is that? What is that path? So I would kind of turn it back on them to kind of really indicate, okay, you're critical. This is why, and this is the reliability that you need. Then I ask, well, what is the role? And I think governance kind of came in a couple times. What are the various roles? I didn't hear a role for like industry standards organizations. You know, is that something, or third parties, you know, that maybe can supplement the role of, I mean, I do get on emails from the UAS side, and there is a big effort within ANSI, you know, involving UAS standards. So I don't know if there's, I assume there is, and like an ISO or other groups, you know, but, and then there's this, I'll stop at that because I think the other ones were just kind of like side conversations that I had afterwards that kind of like, really? They rely on Wi-Fi? You know, and then you say, okay, what do you do about that?
Yeah.
You know?
Have you been in a hospital recently? It's mostly Wi-Fi and Bluetooth, and it's terrifying. So let's open it to the audience. Actually, before we do that, another plug for a paper. Dale recently posted a paper to SSRN. It's called Challenges in Spectrum Operations, that really frames everything that we've been talking about. It's a fantastic paper. Please read it. And
systems engineering perspective.
The systems engineering perspective, yeah. And if you're an editor at IEEE ComMag, you need to anyway. So we've got the first one from Henning, and then we'll work our way around the room. What are your takeaways?
So one of the things for the resilience piece that you talked about is that one of the two insights that I didn't quite hear, namely one is that we now have the ability for many systems to do self-provisioned resilience. As in, it used to be that if you were operating a PSAP, just to take the public safety example that I'm fairly familiar with, well, you relied on your local LEC to provide the circuit. If you were lucky, they provide 2 redundant circuits that were actually redundant, as opposed to going through the same central office in Northern Virginia. And so, but now, at least on the transport side, you can provision relatively easily multiple commercial services that are largely structurally independent in that. You can put a satellite dish on your PSAP roof that will provide more than enough bandwidth for a PSAP. What is hard, however, on one part is that for a consumer, including businesses, to estimate the reliability of the service that they purchase is hard. We measure lots of things. We talked about that during the BEAD panel, for example, or the broadband panel early in the day, and there's no indication on the broadband label how reliable your service is. And increasingly, I would argue that I'd rather have a 100 megabit service that had more nines than a gigabit service that has 5 minutes of outage per day, because then I have to provision another service. So consumer, and I'll take this broadly, enterprise disclosure is a piece that seems to be missing. We need more information as a consumer that also then encourages resilience. And the other piece that was missing was that many of the failures that have happened, like recent Verizon failures, many of the 911 failures, were not classical communication system failures. They were systems failures, some back-end database, some, who knows what went wrong in Verizon, some software updates that went wrong. The Amazon data center outages, the Microsoft outages. So I think we need to design systems where you can swap out not just the communication links, but the whole system. As in, I should be able, as a PSAP, to swap out that instead of going to West/Entrado for my CSAP service, I need to be able to swap to a different service that is completely independent, different data centers, different communication, different software, different vulnerabilities, and I should be able to do that within 5 minutes, kind of a multi-cloud version that people do now. That is the kind of discussion I think that would broaden it beyond just the communication link, simply because that may not be where most of the problems are likely going to be.
Great, thank you. One of the things, just to pick up on your resilience, we can get a label that says what's the speed. One of the things that the 6G white paper on resilience does a very good job on is go through all the possible ways, all the possible metrics for resilience. And the answer is there ain't one. There's lots. And so that's another question of how we communicate that. Any other inputs, questions, suggestions? Yes.
On the resilience framework talk, it seemed to be a lot of mentions of the known knowns. Mm-hmm. And as we write the cybersecurity and supply chain risk management plans for BEAD, it is based on the knowns or a familiar framework from NIST, and admittedly it's flexible and future-proof. But as I also pay attention to Black Hat conferences or DEF CON or any others, they always seem to be a step ahead. And so what is a framework, or what is the resilience framework for the known unknowns? Because it seems to be something that we're not expecting, and fill in the blank, Salt Typhoon or whatever that next one is, it seems to be that future risks. And so is there a framework for that, or how do you think about that as you write these plans?
Do either of you want to comment? Anybody?
I think we should be, at this point of the day, we should be capturing these as interesting ideas for further discussion. Mm-hmm. We've got about 5 minutes left to the official end, and we want to get as many on the table as possible. Yeah. So if we have a few minutes at the end, we should talk about that, but otherwise we should just be popcorning them.
Yeah, okay,
That's a very interesting question.
So we have 1, 2, 3. Yeah, why don't you go, Richard? It's easy. Sure.
Thank you.
Yeah.
So I guess I'm feeling a little bipolar. I feel like we've had 2 conferences pushed into one. So my brain is still in the AI track. And now I'm on the, my old networking engineer track. And I feel like one of the things that was lacking in a lot of our panels was discussion around the role of AI, both on the opposing side and on the defensive side, if you will. We're in an arms race. We've got bad actors are using AI to determine new security threats and ever increasing the size of that threat landscape. And there are also amazing opportunities to use AI for some of the observability and monitoring that we discussed, some of the more efficient use of resources, and perhaps even the spectrum available. So anyway, that just feels like that was an area of focus that I expected perhaps to hear more of in this second part of the conference, if that makes sense.
That's a great point for future conversation. Yep, go ahead. Yep, no, go ahead, Richard. Yep.
Yeah, I was that resilience presentation. First, I like, man, this is amazing stuff. And then I thought about it a little further, and it was like, this is what we were doing 30 years ago on enterprise network architecture. So if you were to put a panel together, say get 4 or 5 network architects, there were nanog regulars, and get them to explain how they manage their enterprise networks, I think you'll find that's pretty much best practices already. That's not to say it was a bad presentation, because that's coming from an academic perspective, and the industry perspective is somewhat walled off from that. But it is, I think, that kind of knowledge is more widespread than people who are embedded in the policy space or in the regulatory space like realize. But I think it'd be good to bring just have a panel of nothing but engineers talking about how they organize their networks and how they deal with threats and how they deal with scalability and how they do, like hot swap upgrades and how they predict failing components before they actually fail. It could be like really insightful. It could be very helpful.
Thank you. Yeah, and actually just to amplify or go back to what the conversation John raised was with Nurul, is like the conversation, not just the engineers, but the engineers and the policymakers around the same table talking about, well, that's what you do. Do you need us to do anything different mutually? So we had another one down here.
Yes, thank you. First of all the talks this afternoon were great. I learned a lot, and I think I speak for a lot of folks. But one thing we don't hear enough about, Pierre, is harm claim threshold. And here's why I'm going to bring that up very quickly.
The check is in the mail.
The kiss up begins.
Harm claim threshold, for those of you that don't know, Pierre spent a good part of his career focusing in on that. I can't think of a better time to bring that out in 2026 to deal with the commissioner's scenarios of resilience in a security domain. We heard from Jade and maybe some other environmental scientists, their noise floors or their signal to noise ratios aren't what ours are at 30, 40 dB in COM. And yet we're treating spectrum as if it's a homogeneous, one and done type of commodity or resource. And I think we need now to differentiate that and drive a more, I'm going to call it variegated, if that's an appropriate term here, a more differentiated form of resource. So we're really managing it for resilience, security, maybe cost effectiveness and other market domains. And your input from the harm claim threshold era, vitally needed. Thank you.
Thank you very much, Rich. Actually, I'd like to generalize that, and I'll wrap up with a few thoughts of my own. I'm not seeing any more hands in the audience. No. I think harm claim thresholds is just a symptom, and the whole resilience conversation allows us to talk about receivers in a new way, because a number of people have said in the course of actually the conference and this afternoon, it's not just the transmitter. So if you want a resilient system, you need to have a way as a policymaker setting expectations to talk about receivers. There's also another thing that's also been cooking away in this conversation, and it's in Dale's system engineering view. How do you characterize the system? If you want to talk about resilience, that's a system property. So how do you frame the expectations that you have as a regulator for systems? My last thought, in terms of things I didn't hear, many of the examples and all the examples that we heard today, fascinating examples, but they were all, even though in some cases, public safety was compromised, they seem to be sort of at retail. It's sort of shoplifting rather than bombing a federal building. And so we haven't really explored the role of nation state actors. We haven't explored the role of the cumulative events. So I don't see any action in the policy space yet. My question is, what will it take? It'll probably take, actually, here's the image. I think we have a sand pile. And the thing with the sand pile is you keep adding grains of sand and nothing happens. But the possibility of an avalanche gets greater and greater. And then one day when you don't expect it, you have an avalanche. So in the resilience security space for wireless, we are going to have an avalanche. My challenge for the community is, what are you going to take to Washington, D.C. the morning after when policymakers are saying, now what do we do? As a community, we need to be ready with advice for them when the bad things happen, that they know what to do next. So with that, thank you very much for joining us. Thank you very much to the organizers. I hope you've had a wonderful time in Boulder and look forward to seeing you here next time.
Join me in thanking the panel.